Hello and welcome everyone to today's webinar on how to connect your data and applications the easy way with REST APIs. Thank you for joining us. My name is Tara Van Cleve and I am a marketing event manager for the developer initiative here at Oracle. So today we're excited to show you how you can easily build REST APIs using Oracle REST Data Services and the Oracle database. We'll also be recording the session and you'll receive the recording via the same email that you registered with for today's event. If you have any questions during the webinar, please drop them in the Zoom chat and the Zoom Q&A areas, and we'll be ready to help answer them there. We've also set up a channel in our developer public Slack called Webinar Ords REST APIs that you can access at the QR code or at bit.ly/odevrel_Slack. And we'll leave that channel open after the event to contact us directly with any questions and to share resources and upcoming events with you. So today's webinar will be presented by Zachary Talke, Senior Product Manager. So without further ado, I will hand it now over to Zach.
Thank you all for being here today. My name is Zachary Talke. I'm a Senior Product Manager on the Database Tools team. Today we're going to be talking about how you can easily bridge your data and applications using REST APIs. So before I go into the material that we're going to be covering today, I just want to talk quickly about the investment of your time that you're going to be making here and essentially why this session is going to be worth your while. So this is a presentation about application programming interfaces, also known as APIs. And as we get further along into the material here, we're going to be focusing on a specific type of them known as REST APIs. Now, as we get started, some questions that you might have top of mind right now is, why should you care about this material? Why should you spend your time here specifically? And why you should listen to me? So to start diving into these questions, there's a lot of different types of technology out there. Why is application programming interfaces specifically worth your attention? And really what it comes down to is when it comes to technology, APIs make the world go round. Over 83% of all internet traffic comes from some form of API, and you're probably seeing APIs in use throughout your day-to-day life without even realizing it. To think about it in simple terms and the easiest way of explaining a definition of APIs, all an API really is a way for two pieces of technology, two software components to communicate with each other. So to go over some examples, when you use a food delivery app and you're scrolling through the different restaurants that are available, you're taking a look at the menus that they have and you're submitting your order and you're getting the tracking details, that's all being handled by an API. When you're logging into your bank's website to see your financial information, your financial details are actually stored in the bank's database and they're being communicated to you via API to that interface dashboard that you're seeing. And if you've ever used a wearable fitness device that tracks health information, all those sensors on it that's capturing the data, it is then passing on that information to your fitness app by API. So APIs are all over the place, and pretty much if you learn what APIs are, how they work, and how to build them, you've just unlocked a huge skill set for yourself when it comes to your software development abilities and what you can accomplish. To go over some quick stats, there's a company, Postman, that releases an industry report every year called the State of the API Report. And during this, they survey a bunch of different software developers who use APIs. 74% of them say that using APIs allow them to leverage existing code rather than having to create new applications. Over 50% of them talk about how APIs allow them to automate different events and triggers. 85% say that in some form or another, APIs increase their productivity. 78% talk about how APIs allow them to create better software. and 87% say that allows them to integrate with their partners faster. So on the topic of partnerships, APIs aren't just for internal use. There is an entire marketplace out there where businesses build APIs around their data and then partner with other companies or sell their APIs to them, where they monetize those data requests via APIs. The global API marketplace value was estimated at about 13.74 billion in 2022. The 2023 numbers are expected to land around 15.67 billion, and it is projected that by 2030, we'll be looking at a total marketplace value of around 50 billion. So if you are able to build effective APIs, you are essentially creating huge business value for your enterprise. And the reason why you should care about all this is because you're essentially seeing a growing marketplace with a lot of value behind it. So you learn how to build APIs, and that is something you can add to your skill set and essentially create your marketplace competitiveness and be able to command higher salary, higher value, and have a really deadly cool tool into your skill set. So why should you spend your time here with this presentation specifically? Well, in this session, we're going to be covering some pretty cool stuff and pretty much running the whole gauntlet of APIs. We're going to start by covering what APIs are and the different types. Then we're going to go into how you can build REST APIs. And after I show you building REST APIs with a more manual example, then I'm going to introduce you to Oracle REST Data Services, also called ORDS. This is an API building and management tool that's completely free for Oracle database users and is a product that our team owns. So rather than essentially trying to convince you of a bunch of words why ORDS is worth your while, you'll be able to see this yourself by going through a more manual building an API example and then seeing how much simpler and easier using ORDS is. And then we're going to wrap things up by going over some resources. I'll essentially point you to where you can access a bunch of different resources after this presentation, including how you can get access to a free Oracle database to start building APIs with. So that way you can take the information that you learn in this session and pretty much hit the ground running when it comes to your own API journey. So why should you listen to me when it comes to this topic? Honestly, what it really comes down to is because this is a topic that I'm passionate about. I started at Oracle a couple years ago as a solution engineer in the sales org. And I was trying to essentially, at that time, learn what APIs are. And I found the topic really unintuitive and confusing. In the research that I was doing, there was a lot of terminology being used that I wasn't familiar with. So I found it a bit disorienting. And basically, my background before tech was finance. So when I moved over to the tech industry and I was making that transition, I was always incredibly grateful for the free resources that I could find that use simple to understand, easy to grasp terminology for everyone, and then built on there with the concepts that were used. So now that I'm on the database tools product management team, and one of our products that we have is an API building and management tool, this is my opportunity to essentially pay it forward and hopefully help you all avoid some of the pain points that I experienced learning about APIs. And I'm also hoping that I make this pretty fun in the presentation as we go along too. I'm not here alone though. We also have my teammate, Chris Hoyna. He is the resident ORDS and API expert on the team. And we also have our boss, Jeff Smith. He is the godfather of our team with over a decade of direct database product management experience. We're going to be going for about 35 to 40 minutes on material and then opening it up to Q&A. They're going to be helping and mostly handling the questions if you have any in the chat throughout the presentation and the Q&A at the end. We all blog about our tech, and if you go off to use ORDs to build APIs after this presentation, feel free to reach out to us. We love hearing from customers. If you have any questions, let us know. Even if you just want to say hi, we're always looking to build those relationships with the people who use our technology so that we can improve it and make it better for you all, essentially. But yeah, so with all that being said, let's get into it. So what are application programming interfaces? Well, chances are, if you were asked to explain this topic now, your reaction might look something like this. And our goal is by the end of the presentation, it looks something more like this. So as I was mentioning at the beginning of the presentation, at its core, an API is really just a way to describe how two pieces of technology can communicate with each other. You essentially have two components. The first is your client, which sends information requests. And then you have your server, which acts according to those requests. You can think of an API like a transportation tube that carries capsules of information. And I'm going to go over some more concrete examples and symbolism to use just to make it a bit easier to grasp. And because today is Valentine's Day, I'm going to torture you all with some Valentine's themed examples and have some fun with it. So in this example scenario that we have myself and my girlfriend, Montana. Montana somehow convinced me to get a tube transportation system between our two apartments so that we can better communicate. This tube transportation system is actually really convenient at the end of the day. It allows Montana to send information requests to me, like what is our dinner plans, and for me to send a response back to her, such as passing her our reservation details. This is essentially how APIs work. Montana is essentially the client, and I am essentially the server. APIs can also be public or private to control who can get access to the information. So if I had a special Valentine's Day present that I only wanted to send to Montana, it's just for her, I can set up the API to be private so that only she has the authorization to make the request to get that present. That way, if my manager Jeff gets jealous and tries to take Montana's Valentine's Day present, he would not be able to do so. But if I had a Valentine's Day present that was made for everyone, so I wanted it to be whoever asked for it could get one, I could set up a public API. That way, Jeff could get a Valentine's Day present after all. And just like your washing machine, there are different styles of tube transportation systems out there on the market, aka APIs. So we're going to talk a little bit about those now. So that company Postman that I mentioned had the state of the API report that I pulled some stats from earlier. One of the things that they also surveyed was amongst API developers, what are the most popular architectural styles of APIs being used? So at a whopping 86% of all API developers, 86% use REST APIs. REST stands for representational state transfer. It's called this because essentially what you're doing with a REST API is you have a specific resource at what's called an endpoint, which is just the location of the API where the resource is present. And when the client is making a request to get the information there, what the client is receiving is a representation of the data located at that point. So that's why it's called representational state transfer. REST uses HTTP protocol, Hypertext Transfer Protocol, for the information requests. And a little bit about HTTP. Essentially, HTTP is the foundation of the internet. It's a request response protocol, and you might be familiar with it by seeing HTTP, specifically HTTPS, at the beginning of the URLs when you go to different websites. S is just adding secure to the end of hypertext transfer protocol. It's an encrypted version. And if you've ever been curious what hypertext actually is, because I actually didn't know until I was putting together this presentation. Essentially, when you get a text display on your computer monitor, hypertext is essentially having text that has references and the ability to access other related texts. So it's kind of like a good way to think of it is it's how the internet works. When you're on Google and you click on a Wikipedia article, that Google page response is a bunch of text, which lets you get to the next page, which is the Wikipedia article, which has a bunch of text and it's all interconnected. And then you can go to other related Wikipedia articles from there. So that's like an easy way of thinking about hypertext. There's a bunch of different types of HTTP requests that you can make in terms of how you can get the information with REST APIs. I'm going to be going over that in the next slide. A little bit more about REST APIs. It supports a bunch of different data formats, and in order for an API to be considered RESTful, it needs to meet certain constraints that I'm also going to go over in a future slide as well. REST is going to be the main area of focus after this slide, so we'll be giving some extra details on that. Next, at 36% of all API developers, what they use, 36% of them use webhooks. Webhooks are great for real-time data interactions. Essentially, what it lets you do is rather than having to manually send a request through an API to get information, you can have a webhook set up where anytime an update is made to data, it will automatically send you the information update. So this is really good as a one-way data transmitter, but it does have some limitations and a limited flexibility. Then you have GraphQL at 29%. GraphQL uses an easy to read JSON-like data structure. Whereas with REST APIs, you have a resource defined at a location and you're making requests on it, such as, hey, get me that resource. GraphQL has it so that clients request data via queries. So the object and what you are trying to get is defined in the request you're making. You're not per se making a request to a predefined resource. You're defining the resource on your side, the client side, instead of it being defined on the server side, as with REST APIs. One of the things that's nice about GraphQL is because you can be specific in your queries, it's pretty low bandwidth versus something like REST APIs. You might be requesting a resource and you only need a part of the data, not the whole thing, but you're still going to get all of it when you make the request. One of the issues, though, with GraphQL is it does have some performance issues. And if you get too specific and complicated with your queries, it can slow down and mess with your performance. At 26%, we have SOAP, Simple Object Access Protocol. This uses an XML, Extensible Markup Language data type. Some highlights of it is the requirements for it are pretty strict. It uses up a lot of bandwidth, but it allows for stateful operations. What stateful operations essentially means is every time when a client makes a request to a server through the API, Montana makes a request to me. Stateful operations allow you to store information on the client making the request that could be helpful for making the operation more efficient in the future. So that's kind of like a little quick summary of stateful operations there. And then last at 25%, we have WebSockets. WebSockets are kind of similar to webhooks where they allow real-time data transmission. But except with webhooks, how this is a one-way transmitter. With WebSockets, you can do two-way communication. So not only do you have that information flowing to you if any updates are being made to the data, but you could also send information upstream to the server as well. Webhook or WebSockets have its problems though, which is why the adoption rate isn't higher. And there's some issues around how a lot of proxy servers don't support it, can't do really load balancing, and it's hard to reestablish your connection if it breaks. There are other API styles on top of this, but these 5 are essentially the big ones that make up the vast majority of APIs being used, with REST in the lead by far. So going back to the topic of HTTP, Hypertext Transfer Protocol, this is the protocol that is used with REST APIs. And this is essentially the type, there are a couple different methods with HTTP that define the different types of information requests that you can use with REST APIs. And I'm going to be going over it. So first you have GET requests. A good way to think of this is to look at the example I was using earlier on. Montana wants to know what our dinner plans are, so she uses a GET request to get this information from me, and I am returning to her in response the information on our dinner reservation, such as the restaurant that we're going to, the address where it's at, the time of the reservation, the price range, things of this information. Next, you have POST. POST allows you to send data to the server to either create a resource or update it. So a good example to think of this is if Montana and I wanted to keep a list of potential date ideas for the future, Montana could use a POST request to send me a date idea for me to add to the list that we're keeping. Put is very similar to POST. It allows you to also create or update a resource. There's some fine-tuned, more in the weeds details on this, but broad strokes, the main difference between POST and PUT is if you send the same POST request over and over, you're going to be creating duplicates of the resource that you're posting. Whereas with PUT, if you just keep sending over that request over and over again, it will just create one copy of the resource. Then you have delete. This is a request that if you have the permissions, you can delete a resource that you specify. Good example of this is we have our list of date ideas and Montana doesn't like one of the ideas on this list, so she sends a delete request to me to remove it. And then you also have batch load. Batch load is like rapid firing a bunch of post requests. It allows you to send a bunch of data all at once rather than having to do individual requests for each piece that you want to send. A good example of this is Montana has a couple date ideas that she wants to send over to me to add to the list. And rather than sending them each individually one at a time, she could send them all as a group through a batch load request. There are other HTTP methods on top of this. I'm going to give you a one-page cheat sheet at the end of this presentation so that you can take a look at examples of all of them, but the ones I covered are the real big ones and what you pretty much need to know for getting started for this presentation going forward. So going over the requirements for what makes an API a REST API, there are essentially 5 or 6 constraints. 1, 2, 3, 4, I think 6 constraints. Yeah, 6 constraints that make a REST API REST, and one of them is optional. So I'm going to be going over that right now. The first is you need to have a uniform interface. This is a uniform way of interacting with the server. And there are 4 guiding principles behind this. And essentially what's meant by uniform interface, uniform way of interacting with the server is you should be able to make a request the same using a REST API to the resource, regardless of the device that you're on. So it should be the same whether you're on your laptop, smartphone, etc. It should be separate from that. The 4 guiding principles behind uniform interface is it being resource-based. You're identifying a resource that you're performing an operation on in your request. The second guiding principle is the ability to manipulate resources through representations. So when a client is making a request to a server for a resource, what is returned should have enough information for the client so that they are able to appropriately modify and delete that resource if they have the required permissions. So manipulating resources through representation is all basically about, hey, these representations that you're sending on the data, what's being transferred by the REST API, it needs to contain enough information so that you have the info you need to act accordingly on these resources. Then the third guiding principle is self-descriptive messages. What this essentially means is the client, the person who is making the request, needs to contain enough information in their message so that the server knows how to properly handle the message and requests being made. And then the fourth guiding principle might be the worst acronym I've ever seen. HADIOS, I don't know, but it's hypermedia as the engine of application states. And all this essentially means is that whenever it's relevant and your server responds to the client with the information request, when it's possible, it should include links and information on related resources. That way, the client can discover other resources more easily. That's the biggest and most kind of complicated of the constraints there. Going on to the next one, client-server separation. Client and servers are kept separate and independent. The reason for this is so that no interdependency is created, and they can each essentially develop, be updated, the technology be improved separate of each other without having to worry about one bottlenecking the other. Then you have statelessness, which is every request needs to be treated as new. There should be no session or history on the client. This is in contrast to what I was talking about a bit before with the SOAP APIs, how they allow for statefulness. So this is pretty much every new request that is made by a client to the server needs to be treated as new. Then you have cacheability. You should be able to store data for efficient future requests. What this essentially means is if a request is made on a server, it should then be able to store this information in the cache for more efficient operations in the future. To give an example that might make a little bit more sense to you all, think about the websites that you go to. The first time you access a website through the URL, chances are it's going to take a little bit longer to load. But after you loaded that first time, data is being stored on that website in your browser's cache. That way, the next time you go on the website, it's going to load quicker because what's going on behind the scenes is it's not passing on all the information to you again. A lot of it is stored in your browser, and it's really just giving you the updates on what has changed since the last time you visited the site. And if you were to say clear your cache or try to access it from a different device that didn't have that data cached, it's going to be slower because it needs to take all the data again. Next is REST API should allow for distributed servers. Essentially, what this comes down to is when available, you should have the ability to have intermediate servers between your client and end server. A good way to think of this is for balancing loads. So you can have your requests that you're making and the operation that needs to be done by the server broken up across several different servers just for performance. And one of the things with load balancing with having a distributed server set is if someone's making a lot of requests via a REST API to an endpoint, by having the load, the requests distributed across servers, you can prevent too many requests from overloading just one of the server. That's kind of like what's meant by like load balancing there. And then you also have code on demand. This is about allowing you to send code or applets, which is small little pieces, small little applications through APIs. The reason this is optional is because while they can be very useful for being able to pass on information and update your applications, aka your client, there's also a huge security risk here with the ability to put code injections. So the reason why this is optional is because it's really, in most cases, only best for internally used APIs, just because of with public APIs, there is that security concern there. So we pretty much covered what the different types of APIs are, a little bit about APIs in general. We went through the different types of information requests that you can make with REST and the constraints of what makes an API considered REST. So now let's go into some actual examples of building APIs. So we're going to be working with the first API that we're building, a table called date ideas. Essentially, what this is just a simple table with a list of available dates that Montana and I are thinking of for the future. We have an ID, a name of what the date is, details on it, the location, the price range, and what our level of interest is. And with this first API that I'm going to show you and we're going to walk through building, this is going to be a bit more manual. So I'm going to show you this and then just show you going through and building an API using ORDs afterwards. So to get started building our manual API, we are going to be using Node.js. What Node.js is a runtime environment. And if you're not familiar with runtime environments, essentially what it means is we're going to be writing our REST API in JavaScript. Node.js gives you an environment to execute and run your JavaScript code in. So that's what's meant by a runtime environment. So to start building this API, we go to Node.js's website and we download it. And then after we do that, there are going to be two modules for Node.js that we want to install. The first one is called Express. Express is a Node.js web framework that has a lot of useful features for building mobile and web-based applications, and it's very popular for building REST APIs. And then we're going to install the Oracle DB module as well. What this is essentially the Node.js module for being able to interact with an Oracle database with your applications easily. And if you're curious what NPM means in that NPM install Oracle DB or NPM install Express, essentially it just stands for Node Package Manager. So we install Node.js, we installed the module for Express and Oracle DB, and now let's write some code for it. So first, I'm just going to create a simple JavaScript file called connection test. This is before we even worry about building our REST API. Let's just break it up into pieces and make sure we can connect to our database okay. So to run through what I have here in the example, first we're going to set our constant Oracle DB to the Oracle DB module. A constant is just a variable where once you have declared it, the value of it cannot be reassigned. So we have our Oracle DB constant. We're going to set a variable for our password. I blanked out there, but you would just put your password in this location. And then we're going to create a check connection function that basically goes in, and what you're doing with this connection is it's going to try to connect to your Oracle database using your username, which in my case is test9, the password, which is going to pass the password variable, and then the connection string, which is going to be on my local Oracle 19c database. The server is going to be localhost. The port for the database is 1521, and the name of it is ORCL PDB. And then if the connection is successful, it's going to pass on a message to the log that says connected to database. And if it encounters any errors during this connection attempt, it's going to pass on that error message so you can see it in your terminal. And then finally, after either you connect to the database or it passes you the error, it's going to attempt to close your connection. And if successful, it will say connection closed successful. And if there's an issue closing the database, it will pass on the error message for that. So returning to the terminal, we're going to run the node command with our file connection test.js. And then you can just see in this example that I was able to connect to the database successfully and then close. So we know with our JavaScript simple application that we're able to do the connection okay. So now that we have the code for the connection taken care of, let's go on and make our REST API. To break down what's going on here in my simple REST API, which is the file I'm calling getDateIdeas.js, we're starting by assigning the constant express to the express module we're using. Same thing with the Oracle DB, with the Oracle DB module. Then we're setting the app constant to our express function. We're going to set the port where we're going to host this REST API on as 8081. And then you put the password here for your database. Very similar to my check connection function that I had in the test. We're going to make a function now called select date ideas. This is going to try to establish a connection with our database using that test9 user again, passing the password on the localhost 1521/ORCL PDB database. It'll let us know if this is successful with the connected to database message. And then after it's established the connection, this is where it's going to actually get the information that we're going to use for our REST API. We're going to use a simple get all REST API here. So it's going to do select star from date ideas, select star, select all. So it's going to give us the full list of date ideas, and that's going to be the query that we're basing our information around here with our get request API. So if any errors were encountered throughout this process, it'll have it pass on the error message in the response rather than the query results. And then after all that's done, it will close the connection. And also there's a little if statement there below where if there's no query results, it will say query sent no rows. This way you know that there's not an issue with the API working. It's just that there's no data based on the request there available. And then at the bottom there, where we have the app.get, what it's doing is we're assigning to an endpoint / date ideas, the function that we have above, the one that's doing the select star from date ideas. So what that basically means there is that get HTTP method that we're using for our REST APIs, we're going to be having the resource available at this location at the end of our URL / date ideas. And that's where it's going to be having this resource, this info of the table of date ideas available there. So to show this in action running, we do node getDateIdeas.js. It'll let us know that our app is now up and listening on port 8081. So then if we go to our URL localhost at port 8081 / date ideas, you can see the list of all the different date ideas available, and we can see that our REST API is now working. Another way to get this information is through a curl command. Curl allows you to send HTTP requests from your command line. So by just doing curl and then the URL, we can also get that list of date ideas as well. Have a quick sip of water, and then we'll get into showing the example with boards. So that was basically running through creating a REST API with JavaScript and using Node.js, Express, and the Oracle DB module. So now I'm going to go get into an example of how much simpler and easier it is to use Oracle REST data services to build an API. I'm going to be using a different database this time. I'm going to be using an Oracle Autonomous Database in the cloud. ORDS is free for everyone, and it's not just exclusive to Autonomous. You can use it on-prem, in the cloud, autonomous, non-autonomous. I'm just using this to show off a different environment, and also so you can actually take a look at the REST API I'm going to build here because I'm going to make it public. But yeah, quick sentence on Autonomous Database in case you aren't familiar. Autonomous Database is pretty cool. It's essentially a version of the Oracle database that automates a lot of maintenance work for you. So if you're interested in that, I definitely recommend checking out more information. So on our databases dashboard, we're going to click the Database Actions button and then go to SQL. From here, we'll see the date ideas table. It's essentially the same table that I had in the other database, and we're going to be making our REST API around the table here in our autonomous database. So we're going to be showing off two methods. The first is auto resting. So on that date ideas table there to the left side, you're going to right click that where I have the red box around it, click rest, and then enable. Then you put what we want the object alias to be, kind of similar to how we were naming with the Node.js REST API. We had that date ideas location. We're doing the same thing, and you can see right below that our URL formed with date ideas as the resource location. From there, you click enable, and essentially you just created a bunch of different HTTP methods, essentially a full REST API for that entire table with just 2 clicks. So I'm going to be showing off all the different operations you can do with this. But yeah, that is a whole lot easier than having to worry about a bunch of JavaScript code. And what I did here was all just to create a GET request. And I'll be showing off in another slide or two how you can do a bunch of other operations with the table that we auto rested through ORDS, including like get, post, delete, etc. And it really just takes a lot of that maintenance work out of your hands. So to take a look at the operations we can do, back under the REST tab, click curl commands. And here you can see it will have the curl commands just pre-made for you. So you can plug that into your terminal and try it out. There's an option to get different formatting based on the operating system you're using, Windows, Mac, Linux. And as you can see from the list there, get all, get single, post, batch load, you can just click on one of them like post and it will give you the specific curl command. In this case, if we wanted to say post something to the date ideas list, you can just put the information in those fields. It will pre-fill out for you, and then you can plug that into your terminal to send the request. So it makes all this very simple and easy. To show this off in the terminal, going back to our database page, if you click on the little code icon in the top right and then Cloud Shell, it will open up a command prompt for you just directly in the Oracle Cloud. And then from there, if we put our curl commands, we can see the information returned to us. And same thing where if you just put that URL in your browser too. And I believe Jeff is gonna, if you want to just check out this API yourself, it's live right now. Jeff's gonna put it in the chat. So you can just plug this into your URL and see the list of date ideas here. So that was going over auto resting a table. I'm going to show, oh, actually, first, there's one more thing I'm going to show you too. That's pretty cool. How ORDS will auto generate your documentation surrounding this. So if you go to database actions and click rest, and then click auto rest, and then you go to open API view, what this does is it will give you your open API documentation, also known as Swagger documentation, around the REST API that you created. So open API documentation is a way of describing what your API does in nice human readable format so that anyone can essentially understand it And OpenAPI is really a way to have a universal guideline for a set of instructions around your API. So your whole point of making APIs is so that people use them. But if your instruction manual isn't good or just non-existent at all, that's going to be a huge problem. And APIs pretty much live or die by how good their documentation is, because if you don't know how to perform operations against the resources, it's not easy to use. So kind of talking about that example that we had with Node.js, all that JavaScript code that we had, that was just to create a simple get all request. But meanwhile, by clicking two buttons with auto rest, you can see with our OpenAPI documentation here, we can do delete operations against it, the get operation, we can get individual records, we could do put, post, and all of this documentation is automatically generated for you versus with the Node.js, that was just to do one document or one operation. And if you wanted to add more, you would have to code all those extra operations and then create documentation across all of those operations so that people know how to use it. So I really can't emphasize enough how much time saving there is here with ORs, both in terms of creating the APIs, but also not having to worry about documentation. It really is huge. And we're talking about getting stuff done in the matter of minutes to hours versus days to week. And with the OpenAPI documentation on a dashboard, you can even go in and try out the different operations against your API. In this example, I'm just plugging in the ID 1 and it's showing the first date idea on the list. And then also returning to this dashboard, you can click Export OpenAPI. And it will give you also an easy to export version of the OpenAPI documentation as well. So we're starting to run a little bit low on time. So I'm just going to quickly go through one more example of building a REST API with ORs. This time we're going to be going through making the components ourselves in a custom SQL query, using a custom SQL query for our API rather than auto resting. So this time we're going to be using a different table called dinner plans. And what this has is a list of dinner plans that Montana and I keep track of in a list. That way we can just know what's coming up on our calendar and dinners that we've had in the past. It has things like the restaurant name, the address, the date and time of our reservation, and the price range. So going back to this REST dashboard, we're going to be clicking on modules, then create module in the top right. We're going to name our module, I'm just going to call it com.oracle.webinar.api. And the URL path I'm going to start to build, we'll start with API for the base path. In that preview URL right below, you can see your URL start to be built. And there's essentially three components with an ORDS REST API: the module, the template, and the handler. Think of it like boxes inside of boxes. You have templates that are in your module and handlers that are in your templates. And I'll talk a little bit more about that in a second. So from there, you can click create. And then our module's created, so we're going to create a new template. From here, we're going to make our URI template. So we're going to have, because we're talking about a list of dinner plans here, we're going to make our resource called dinner. And what we're going to have for our bind variable, which is essentially where you're going to input information, we're just going to use the bind :ID as the placeholder there. So from there, we're going to create our handler. So the handler is where you're actually specifying the type of HTTP request that you're going to make. What we're going to do is create a GET request here, and this is where we actually put the SQL statement that we want to build our API around. So with ORDS APIs, you can build your API around a custom SQL statement or PL SQL procedure. So what I want this REST API to do is I want to be able to input a date and then it will give me all my upcoming dinner plans that are on that date or after that date. So to do this, we're going to do select star from dinner plans where date and time is greater than equal to to date :ID and then the year, month, date formatting. To date will just take my input of a string and convert it to the date format. The :ID is essentially the location where my input is going to go. It's the placeholder. The reason I'm not naming it something like :date is because date means something in SQL. So although it's not the most descriptive thing, just know that :ID is where the input is going for the date, as in year, month, day. And then just to talk quickly about the three components a little bit more. The handler is where you define your HTTP method in the SQL statement. Handlers are organized by their template, which can be thought of. The template is the noun, aka that /dinner in the URL that we're performing the action against, the verb against, aka our GET request of this SQL query. And then your modules are a logical collection of your templates. So that's a little bit of a way to think about that. So we click create, and then we can test our API by plugging in our date. So we'll do show me all of the dinner plans I have that are on or after tomorrow, the 15th. And then it returns that I have a dinner reservation for tomorrow at 5:30 p.m. And then if you go and take that URL that you have available and you plug it in with your input value at the end, you can see that it will return this information as well. And then the same thing, you can plug it in with the curl command and see it too. So that's basically the presentation. We covered what APIs are. We went over how you can build a REST API more manually, and then we showed off ORDS a bit. I have a bunch of resources available all in one place just to make things easier for you. It's on my blog at telkey.tech/blog/API webinar resources. And this will essentially give you a bunch of goodies to jumpstart your API journey with. We have a bunch of different options for free Oracle databases you can access to build APIs with. You can use ORDS completely for free with an Oracle database. I have a link to the latest version of ORDS and a bunch of information such as the ORDS documentation, articles across Jeff, Chris, and I's blog, and a free ORDS hands-on workshop that you can go to get your hands a bit dirty with building APIs yourself. And then I also have some other things that might be of interest to you. One of them being our SQL Developer for VS Code extension is now live, so highly recommend you go and check that out. It is very cool. Not sure if Jeff wants to say another sentence or two on that in a second.
It's the future of SQL Developer. And also, I just want to say real quick, thanks to everyone for spending Valentine's Day with Zach and hanging out with us. There were tons and tons of great questions. If we didn't get to all of those to your needs, we're really easy to find. Find us, ask us those questions, and we'll also be happy to set up calls for your organizations if you want demos on how to get started with ORDS.
Thank you again, everyone, so much for joining us here today, and we hope to see you at the next one.